Hi everyone, welcome back. In this video, I'll discuss about laws of logarithms. There are three standard laws of logarithm. The first law is known as product law. Log base A m into n. M is multiplied by n equal to log base A n plus log base A n. This law is known as product law, and this law is applicable for extension, means many multiplications, something like this: log base B ABC. It can be written as log base B A plus log base BB plus log base BC, and so on. If you have more multiplication, it'll get added up. The second law is called quotient law, division law. Log base A m divides by n equal to log base A m minus log base A n, and this law can be used vice versa. In between logarithm, if you have minus sign, then m will divide n. If there is plus, it multiplies. If there is multiplication, it gets added up. If there is division, it gets subtracted. Third one is called power law. Log base A n to the power of n. It can be written as n log base A n. This is power law. When you have number of variable in front of logarithm, it can go to the power. If there is power, it can come to the front of logarithm. These are three standard laws of logarithm. Then you have some deductions, or it can be used as rule. Log base A to the power of x can be written as x. Number 5. A to the power of log base A x can be written as x. Look at these two. And these two are applicable in several sums. If there are some more rules, I'll be deducing those rules to simplify the sums. Deduction will be done. Product law, quotient law, power law, deductions, and it'll be a bit confusing. You need to understand the steps carefully, otherwise the calculation based on standard laws of logarithm will be lengthy, and you need to use lots of technique to solve it. Something like this: log x to the power of 3 minus log x to the power of 2. Look at this one. In between logarithm, you have minus sign. There is no base given, means we consider it as base of 10. Minus sign, you write 1 log. First one goes at numerator, x cube. Second one goes at denominator. This is division law. Minus sign means these two divides. Then we simplified log square and cube x to the power of 3 minus 2. Take it up to numerator, it becomes minus log x is left. 3 minus 2 is 1. Or you can cancel this. Similarly, suppose you get question like this. Log x to the power of 4, division sign log x to the power of 2. This entire log is divided by the second log. You cannot use the formula here. So what do? We take this one to numerator. Log x to the power of 4 log x to the power of 2. Now we proceed. We cannot cancel log directly. You have exponent, that means we are applying power law here. This power will come in front of logarithm. 2 log x, 4 log x, 2 log x. Now we can cancel log x. You cannot cancel only log here. 2 times, answer is 2. Similarly, you can have sums like this. Log 16, log 81, log 27. Look at this sum. In between you have multiplication. So in order to simplify this, log 16 has to be changed. It is log 2 to the power of 4. You can find prime factors. Put multiplication signs. Similarly, this can be written as log 3 to the power of 4. 81, 327, 39, 33. Denominator log 3 to the power of 3. And cancellation of logarithm is not allowed. After this we use power law. 4 goes in front of logarithm. 4 log 2. 4 log 3. 3 log 3. Now log 3 and log 3 cancels. 4 multiplied by 4 is 16 log 2 divides by 3. Or you can simplify this and write log 2 to the power of 16 divides by 3. Or you can leave it in this form, or you can simplify this. Similarly, suppose you have a question like this. Log 125 divides by log root 5. Look at this question. Log 5 to the power of 3 log 5 to the power of half. Use power law now. 3 log 5, exponent goes in front of logarithm. Half log 5 cancels. 3 into, take reciprocal of this, you get 6. Answer is 6. Similarly, you can have a question like this. Log 16 minus log 2 divides by log 4. You cannot subtract logarithm directly. If there is minus sign in between logarithm, means that it is division law. Out of these two logarithms, you need to write one log. 16 will be kept at numerator, 2 will be at denominator. Similarly, this you can write log 4. Now you can cancel this. So you are left with log 8 divided by log 4. You cannot cancel 4 2 times 8. That is not allowed. 8 can be written as log 2 to the power of 3. 4 is written as log 2 to the power of 2. Apply power law. 3 log 2. 2 log 2. Now you can cancel. Answer is 3 upon 2. Don't try to cancel 4 ones are 4. Log 4 2 times. That is not allowed. And in the beginning only I said it is bit confusing. You need to follow the steps. So whatever sums I have done, in similar way you can solve exercise 8.2. Question number 1. There are around 6 sums. I did similar 6 sums here. Now let's do question number 2. Question says that evaluate the following. Log base 10, division sign, fifth root of 10. Look at this simplification. What do? We write on log 10 is divided by fifth root. So you write 10 divides by 10 to the power of 1 upon 5, fifth root. It is in the form log n upon n, and when there is division means it is taken as minus. So we write log 10 minus log 10 to the power of 1 upon 5. Log 10 we write as it is minus, power comes in front of logarithm. There is no base given, so we always take base as 10. And in the beginning of logarithm, I have told you log base a is always equal to 1. Base and the number is equal means it is taken as 1. 1 upon 5 again into 1. 1 minus 1 upon 5. Take LCM, you get answer as 4 upon 5. You can do question number 2-1 in similar way. Question number 2, part 2. 3 plus 1 upon 3 log 10 to the power of minus 4. I'm changing the values so that it will be easier for you to simplify in the similar way from the exercise. We write as it is 3 plus 1 upon 3 power, we bring it in front of logarithm, log 10. 3 plus into minus is minus, 4 upon 3 log 10 is 1 because base is considered as 10. 3 minus 4 upon 3, LCM is 3, 9 minus 4 which is equals to 5 upon 3. Similar sum, solve it yourself from the exercise. Question number 3, 2 part 3. It is 2 log 3 plus log 8 plus 1 upon 2 log 16. Look at this question. You can solve it by using exponential part. Take this power to number to the power log 3 to the power of 2 log 8, take it to the power log 16 to the power of 2 log 3 to the power of 2 is 9 plus log 8 plus log 16 to the power of half means root of 16. Root of 16 is 4. In between logarithm you have plus sign. So out of 3 logarithms you need to write 1 and multiply the numbers. 9 into 8 is 72, 4, 8, 28. So it is log 288. Similar sum you have in the exercise. You can solve it. Same question, suppose you have minus sign here. Minus sign. So we solve it as log 3 to the power of 2 plus log 8 minus log 16 to the power of half log 9 plus log 8 minus log 4. In between first and second logarithm you have plus sign, means these two numbers will multiply. You write 1 log out of these two, 9 into 8 minus log 4. In between first and second logarithm there is minus sign, and if you have minus sign, so 1 logarithm is written 9 into 8 divides by 4 2 times. You get 9 into 2 is 18. Similar question but sign. Plus means multiplication, minus means division. Question number 4. Look at this question. It is 2 log 10 to the power of 3 plus 3 log 10 to the power of minus 2. 1 upon 3 log 5 to the power of minus 3. 1 upon 2 log 4. You can take it to the exponent and solve, or you can bring the exponent to front of the logarithm and solve. Choice is yours. I am taking this in front. 2 into 3 log 10. 3 into minus 2 log 10. 1 upon 3 into minus 3 log 5. 1 upon 2. 4 can be written as log 2 to the power of 2. Look at this calculation. 6 log 10 plus into minus is 6 log 10. Minus into minus is plus. 1 upon 3. You can cancel log 5. 1 upon 2 into, bring this power here, log 2. So what happens here? You get 6 log 10, 6 log 10, log 5, cancels log 2. You can cancel directly 6 log 10 minus 6 log 10 plus minus cancels log 5 plus log 2. In between you have plus sign. So 1 logarithm 5 into 2 log 10. There is no base means 10. Log base 10 is 1. Similar sum, not similar sum, exact sum. So please do solve sums from exercise 8.2, question number 2.1, 2.2, 2 part 3, 2 part 5, 2 part 6 and 8. Similar way. Now look at the third sum. Question says that express the following as single logarithm. Question number 3.1. I'm changing the sum. 3 log 2 minus 1 upon 2 log 36 plus log 6. Look at this one. Goes to the exponent log 2 to the power of 3. You can take it to exponent, or 36 can be written as 6 to the power of 2. Bring here and multiply. Log 36 to the power of half. Log 6. Log 2 to the power of 3 means 8. 36 to the power of half means 6. Square root of 36. Log 6. Look at the calculation. You can cancel this or you can use log. In between first and second logarithm there is minus sign. So you write 1 log 8 upon 6 division plus log 6. In between first and second there is plus sign, so it multiplies 1 log 8 upon 6 into 6. Cancels. You get log 8, or you can cancel here. Log 8 is the answer. Question number 3, part 2. Log base 10 to the power of 5 log base 10 2. 3 log base 10 4 plus 1. You cannot simplify it directly until you don't change this one in terms of logarithm. Goes to the exponent log base 10 5 to the power of 2 minus log base 10 2 goes to the exponent log base 10 4 to the power of 3 plus 1 can be replaced by log base 10 10. 1 is equivalent to this. So we get log base 10 25 log base 2 log base 10 4 4 4 multiply 3 times 64 log base 10 10. You can solve it directly or you can start solving individually. First and second logarithm minus sign. So we divide it 25 upon 2. Copy this as it is. Log 10 64 log 10 10. In between logarithm you have plus sign. Plus sign means product law is applied. Log base 10 25 upon 2 into 64 into 10. You can cancel it. 232 times log base 10 multiply it. 25, 32, 10, 4, 5, 15, 7, 0, 0, 8 into 10 will be 8,000. This is the single logarithm. So in similar way, you can solve question number 3. I did number 1. I did number 2. You can go for number 3. You can do number 4. Try to solve few sums from the exercise. Thank you very much. Stay home, stay safe. Remember the laws of logarithm.